three key plasma protein systems that contribute to inflammation. One of which is the complement system. And the complement system is a plasma protein system that actually does more than just contributing to inflammation, but inflammation is one of its key outcomes. So the complement system is made up of many circulating plasma proteins that are activated in a cascade of enzymatic reactions. And this protein system accomplishes three purposes. So when it's activated, it accomplishes three things. It promotes inflammation, it causes direct killing of pathogens, and it tags pathogens for later killing. And that tagging for later killing is called opsonization. Okay? Opsonization, you tag a pathogen with some protein that we call an opsin, and that makes the pathogen much more likely to be phagocytized by one of our scavenger cells. So we're going to talk about how the complement system is activated, and then talk a little bit more about, once it's activated, what outcomes occur. So activating the complement system, there are three general ways to activate complement. We're going to talk about the general ways, and then we're going to talk about the specific mechanisms. The three general ways to activate the complement system is, number one, just the presence of a pathogen. If a pathogen enters the bloodstream and can interact with the complement plasma proteins, then the complement system can be activated. Okay, so simply the presence of a pathogen in circulation can activate complement. Secondly, you can activate complement as part of a systemic inflammatory response, and this is our acute phase response that I mentioned in class. So this systemic inflammatory response, which we'll talk about later, involves the release of key proteins by the liver that increase the likelihood of complement activation. Number three, complement can be activated by our adaptive immune system, specifically through the release of antibodies. Okay? So antibodies can play a role in increasing the likelihood of activating the complement system. So those are the general ways to activate complement. Let's talk about specific pathways. So when we talk about complement activation, we think of it as having three basic pathways. So there's something called the classical pathway, the mannose-binding lectin or MB-lectin pathway, and something called the alternative pathway. So as I said, the complement system is composed of several plasma proteins that get activated in this cascade of reactions. So you have multiple complement proteins that get activated in series. So one activates the other, which activates the other. Now, if you notice, all three of these pathways are different ways of activating the system, but those three mechanisms converge on the activation of a key complement protein called C3 convertase. Okay? So these three pathways are just three different mechanisms to activate a common key complement protein, okay, called C3 convertase. Because once C3 convertase is activated, then you get all of the outcomes of complement. Okay, so it's kind of all or none. You activate complement, then you're going to get all of the outcomes. So let's talk about this classical pathway. And this classical pathway is the most complicated mechanism for activating, or the most all-inclusive pathway for activating complement. Compared to the MB-lectin and the alternative pathway. So let's just skip ahead for a second and talk about the classical pathway for activating complement. The classical pathway involves starting with the first complement protein, or C1. Okay? And C1 is going to start the cascade in the classical pathway. And C1 can start the cascade or become activated in three different ways. The first way is that C1 can actually bind directly to the pathogen surface. So the pathogen is in the bloodstream, C1 finds the pathogen, binds to it and becomes active, and that starts the cascade. The second possibility is that C1 can bind to a protein that is already bound to the pathogen surface called C-reactive protein, or CRP. Now, CRP, which we will talk about more later, CRP is a protein that the liver produces when we are experiencing a systemic inflammatory response. So CRP is a protein that is released by the liver during a systemic inflammatory response. And C-reactive protein, its purpose is to bind to the pathogen surface and increase the likelihood of complement activation by binding to the C1 protein and starting the cascade. So this pathway, or this mechanism involving C-reactive protein, is how complement gets activated, one of the ways complement gets activated as part of a systemic inflammatory response. The third possibility for the classical pathway is that C1 is going to bind to an antibody which is bound to the pathogen surface. So in this example, we've already mounted an adaptive immune response. Our body is producing antibodies specific to the pathogen, and those antibodies are, in this example, making activation of complement more likely by enhancing the probability of C1 binding to the pathogen. Okay. And so this is an example of how our adaptive immune system can use the complement system in a very targeted way to fight a very particular pathogen. Okay. So these are all included in the classical pathway of complement activation. The second pathway, the MB-lectin pathway, involves another protein called MB-lectin, or MBL. Okay? MBL, it's written right there. MBL is similar to C-reactive protein, CRP. Okay? MBL and CRP are both produced by the liver during systemic inflammatory responses. Okay? And again, their purpose is to increase the probability of complement activation. Okay? And so the MB-lectin pathway involves this protein, MB-lectin, binding to the pathogen surface, and then that binds to the second complement protein, C2, and that triggers the cascade. Okay? So this MB-lectin pathway is entirely part of a systemic inflammatory response. Okay? It's activating complement through the release of this acute phase response protein, MB-lectin, and triggering complement. This third pathway, the alternative pathway, again, only requires the presence of the pathogen. Okay? So the alternative pathway is actually the binding of the inactive C3, okay, the third complement protein, to the pathogen surface. Okay? So inactive C3 encounters the pathogen, binds to it, and then becomes this key protein, this C3 convertase. Okay? So we've got three general mechanisms for activating complement. And those three general mechanisms or pathways encompass these three general ways, right? The presence of the pathogen, stimulating complement as part of a systemic inflammatory response, and stimulating complement as part of an antibody-mediated adaptive immune response. Okay. So that's activating complement. What do we get when we activate complement? Okay. So what we get, and the outcomes of complement, are on the bottom here, okay? And there's three general categories. The first one is inflammation. Okay? Many of the terminal proteins that are activated in the complement system are very strong mediators of inflammation. Okay? They have strong vascular effects. They help recruit these phagocytic cells that are a part of inflammation. Okay? So the complement system promotes inflammation. Another outcome of complement is this opsonization that I mentioned. Okay? So some complement proteins bind to the pathogen surface and increase the likelihood of phagocytosis by our scavenger cells. Okay? So we have opsonization of pathogens. And then the last outcome of complement is really actually the most remarkable one. And it involves the most numerous complement proteins. So you can see this long list of complement proteins. And what happens here is these complement proteins, when they become active, they actually bind to each other and they form a channel. They form a membrane channel, and that channel gets inserted into the pathogen's cell wall. And that insertion of this channel into the pathogen cell wall causes water to rush into the pathogen, and it causes lysis of the pathogenic cell. So basically directly kills the pathogen. And this channel that these complement proteins form is called the membrane attack complex. Okay? Because it's a complex of membrane proteins that attack the membrane and cell wall of the pathogen, okay, and directly causes it to die. So complement, as you can see, once you trigger this cascade, you get several outcomes that are very, very potent fighters of infection. So it's one of the strongest, most important components of our innate immune system. Another plasma protein system is called the Kynan system, and it also plays key roles in inflammation. The Kynan system involves a group of plasma proteins that when inactive, they are called kyninogens, and when they are active, we call them kynins. Okay? And bradykinin is a key kynin in this cascade. And when the kynins are activated, they do several things to stimulate or to fight pathogens. Okay? Number one, they help stimulate the complement system. Okay? They make activation of complement more likely to occur. Number two, they promote localized vasodilation and increased permeability. So they enhance the vascular effects of inflammation. They also make inflammation painful. They activate pain receptors. Okay? And then finally, they act as chemoattractants. Okay? They increase the migration of neutrophils to the area, especially, they increase the attraction of, or the migration of leukocytes to the area, especially neutrophils. Okay? So how do we activate this Kynan system? Well, there's a couple of ways that the Kynan system can be activated. Number one, the enzyme that's needed to activate the kyninogens into active kynins is also the same enzyme that corresponds to the activated clotting factor 12. Okay? So the activated clotting factor 12 produces, when active, produces the enzyme that activates the Kynan system. And as we'll see when we look at the clotting system, this factor 12 is usually the first clotting protein or clotting factor that's activated when a clot occurs as a result of blood vessel damage. So activated clotting factor 12 occurs as a result of vascular damage. And so that can activate the Kynan system. Additionally, when neutrophils arrive at the site of inflammation, they also release this activated clotting factor 12. Okay? And that triggers the Kynan system. Okay. And if you notice, we have just a little bit of a loop going on here, where activated Kynan attracts neutrophils, and then neutrophils release the enzyme necessary to activate Kynan. Okay. So as you can see, this is part of the way that inflammatory responses amplify very quickly once they're triggered. Okay. So let's look at the clotting system. So the clotting system, the clotting cascade, it involves two basic activating mechanisms, and a series of clotting factors that are activated in a cascade. Okay. So the two basic ways that the clotting cascade is triggered is classically triggered is damage to the blood vessel surface, which releases, which activates this factor 12, and damage to tissue outside of the vessel. Okay? Damage to tissue outside of the vessel produces a mediator called tissue factor, and that activates the clotting cascade, but it activates it further down in the cascade at factor 10. Okay? So you can have damage to blood vessels triggering the system, or you could have damage to tissue outside of the vessel triggering the system. Okay? And then, of course, if the Kynan system is triggered, you get this activated factor 12, and that also is going to trigger clotting. Okay? So no matter what triggers the clotting cascade, the outcome of triggering the clotting cascade is obviously producing a blood clot. But the key step in producing that blood clot involves the conversion of a protein called prothrombin, the inactive version of a protein called prothrombin, and turning that into thrombin, active thrombin. Because thrombin is the final key enzyme that actually produces the blood clot. Okay? Because thrombin converts the protein fibrinogen into what we call fibrin. Okay? Now, fibrinogen are these long strands of proteins that are in circulation. Okay? Fibrinogen are these long strands of proteins that are in circulation, and in the presence of thrombin, they form fibrin. And what happens when we form fibrin is these long strands of proteins actually start to cross-link with each other. Okay? They actually starts to cross-link. And that cross-linking of these long strands of protein is what actually forms the blood clot. I'm going to go forward into the next slide. And what we're looking at here is actually a blood clot, a very high resolution zoomed in image of a blood clot. And so what we see with this is we see red blood cells that are suspended in this netting, this meshwork of fibrin proteins. Okay? So the cross-linking of the fibrin proteins creates this netting that traps blood vessels and actually creates the blood clot. Okay, so that actually is what a blood clot looks like and what triggers it. Okay, and the final connection between this clotting cascade and other components of inflammation is in this activated thrombin protein. So thrombin, in addition to producing fibrin, thrombin also promotes inflammation. Okay? Thrombin in and of itself also enhances some of the vascular events of inflammation by activating a protease receptor that stimulates, among other things, edema. Okay? So the clotting cascade is intertwined in these inflammatory process and inflammatory inflammatory process and inflammatory mediators, both through the Kynan system and also by directly promoting inflammation. Okay. And so this slide is just to give us some examples of how these different components of the inflammatory response, how these different inflammatory mediators are connected to one another. Okay? This is just an example of how they are connected to one another. And I've categorized these two sides of the slide are categorized by the two major events that stimulate inflammation. So we have on the left tissue and or vascular injury, and on the right the presence of a pathogen. So let's look at tissue or vascular injury. So tissue and vascular injury is going to cause, let's look at the first arm here. Tissue and vascular injury is going to cause activation of mast cells. It's going to cause the mast cell to degranulate, synthesize these arachidonic metabolites like prostaglandins and leukotrienes, and basically it's going to promote inflammation. Okay? So tissue and vascular injury through a classic mast cell activation promotes inflammation. Okay? Tissue and vascular injury will also cause activation of the clotting cascade. Okay? And activation of the clotting cascade will obviously lead to the formation of a blood clot. Activation of the clotting cascade through the production of thrombin will also promote inflammation, especially edema. And activation of the clotting cascade also activates the Kynan cascade. Okay? It produces that activated factor 12 that converts kininogens into active kinins. Now, of course, the activated Kynan cascade also increases the activation of the clotting cascade. So there's this back and forth going on between activation of clotting and activation of the Kynan cascade. Okay. So, and then the last arm in this, tissue and vascular injury, activates the Kynan cascade, which is going to go back and forth stimulating clotting. And activated Kynan also produces pain. It stimulates the complement system and it promotes inflammation. Okay? And as the Kynan system stimulates complement, the complement system is going to potentiate this inflammatory response. Okay? So you notice that many of these arrows are converging on promoting inflammation. This is one of the many ways that inflammatory responses, acute inflammatory responses, they really flare up very quickly. They amplify very, very quickly. On the other end of the slide, we have presence of a pathogen. And presence of a pathogen can, of course, happen along with tissue and vascular injury, but let's just look at it in isolation. So presence of a pathogen is capable of activating the complement system, and that will cause inflammation, opsonization, and the formation of the membrane attack complex. Presence of a pathogen will also activate the macrophage. The macrophage releases cytokines that trigger inflammation. That inflammation is going to cause the migration of neutrophils to the area. Neutrophils release activated factor 12, which activates the Kynan system along with the clotting system. Activated Kynan causes stimulation of complement, further stimulation of the clotting cascade. It promotes more inflammation and it causes pain. Okay. So this is just a look at some of the ways that these systems are interrelated.